Hello guys, my name is Eginali. We want to look at the objective part of this particular one, question, and we'll be looking at all these questions one after the other. We have about close to 8 questions we want to solve. We have 6 on the board already, so we want to quickly do that. Now, you say which of the following is not a step in the principle of mathematical induction in establishing the authenticity of a mathematical expression. Now, this option A says assume that the mathematical expression is true for n equals to k. You cannot, okay, you can assume that the mathematical expression is true for n equals to k. That is correct. If it is true for n equals to 1, correct. B says show that the mathematical expression is true for n equal to 1. I think that's also correct. Assume that the mathematical expression is true for n equal to k plus 1. No, you show that it is true for n equals to k plus 1. I think now it's wrong. The option D said if the mathematical expression is true for n equals to k. Excuse me. So then that means you show if the mathematical expression is true. This one is show if the mathematical expression is true for n equal to what? K plus 1. Yes, you show. That means in this case now, assuming the mathematical expression is true for n equal to k plus 1 is wrong. So which of the following is not correct? So that is wrong. Option C is wrong. So in that, let's go to number 2. And I'll take what? I have to take this one off. So I can have a space for number 2. Now the number 2 says that if the sum of n, the sum of r from 1 to n is equal to n equals to n plus 1 over 2 is proved by mathematical induction, then the n at n equal to k plus 1 of that expression or that equation is dash. So anywhere we see k, n equal k plus 1, so we have k plus 1 into bracket k plus 1 plus 1 all over 2. So our answer will be k plus 1 into bracket k plus 2 all over 2. So I'll go for option D, which says what? K plus 1 k into bracket k plus 2 all over 2. Option D is the correct answer for number 2. We go to number 3. It says using mathematical induction prove if this sum of r starting from 1, r squared starting from 1 to n greater than or equal to 2n plus 1 for n greater than or equal to 3 when n equals to k plus 1 for the right hand side of the equation. Using the principle is obtained by dash. So what we are going to do, we have the left hand side and we have the right hand side. So the right hand side of the equation is what? 2n plus what? 1. So we substitute our what? K plus 1 there. If you put k plus 1 into that right hand side, which is what? Sum of r squared r equal to 1 n greater than or equal to 2n plus 1. Substitute what? In place of n, 2k plus 1 plus 1. But I would have 2k plus 2 plus 1, which will give us what? It will give us 2k plus what? Plus 3 on the right hand side. And that should be what? Option D. Now we go to the next one. It says number 4. It says if the sum of what? R squared starting from 1 and end what? With n is what? Equal to n into bracket n plus 1 over 2 all square is proved by mathematical induction. Then the principle at n equal to k plus 1 is obtained by dash. Now, what we want to do again is we make use of the right hand side because the right hand side contains n. So the right hand side contains n. So what we want to do is to what? Simply what? Sum of what? R1 then n r squared equal to n into bracket n plus 1 all over 2 all square. So what we're going to do is to what? Put our n equal to k plus 1. Put it into the expression according to the question on the right hand side because that contains n. So I have k plus 1 into bracket what? K plus 1 plus 1 and in place of n we put k plus 1 plus 1 all over 2 all square. We break it down, we would have k plus 1 into bracket what? K plus 2 all over 2 all square. I think that should be in the option, which is option B, which is k plus 1, k plus 2 all over 2 all square. Option B. Now, number 5. By the use of mathematical induction, they prove that 3 raised by 2n plus 1 plus 2 raised by n plus 2 is divisible by dash. Now, I have done the normal way. Let me show you the shortcut of doing that. Go and watch my last the mathematical induction analysis, and you will see that we have done the normal thing. So, but if you want to solve objective case, you can say 3 raised by what? 2n plus 1 plus what? 2 raised by what? N plus 2. Now, what we want to do now is to what? Anywhere we see n, put 1 there. So you test for what? When n equals, show that it is true for n equals to 1. So if you do that, you put 1 here, what have what? 3 raised by what? 2 times 1 plus 1 plus what? 2 raised by 1 plus what? 2. That will give us what? 2 times 1 plus 1 is 3 raised by 3 plus what? 2 raised by 3. And if you do the addition effectively well, you only have 27 plus what? 8. 27 plus 8 should simply give you 35. And 35 can be written as 7 into brackets 5. Meaning 7 times 5, which we learn our basic mathematics. And this one is divisible by 7. If we can divide this one by 7, we are going to see that it will divide without remainder. If we check the option there, 35 cannot be divided by 3, 35 cannot be divided by 2, 35 cannot be divided by 11, but could be divided by what? 7. So I will go with option D for that question. Let's go to number 6. Question number 6. Question number 6, quickly. Let's go to number 6. Now, that is the shortcut for that one. So after putting 1 there, you get the number, then try with all the options, then you will get your answer. Now, the next one says, if what? Sum of what? R, starting from 1 and ending with n, is equal to 1 over r into bracket r plus 1 equal to n over n plus 1. It's approved by mathematical induction. The principle at n equal to k plus 1 is dash. So what we do is that we substitute n equal to what? K plus 1 to the right hand side of the equation, not to the left hand side. So we work with the right hand side, because why? The right hand side carried n. So we do this with what? By substituting k plus 1 for n, by k plus 1 plus 1. So what we have k plus 1 over k plus 2 as our answer on the right hand side of what? 1 over r into r plus 1, starting from 1 and end with n. So I think the option to that question is, the option is not complete, but that is the right answer to that question. K plus 1 over what? K plus 1 plus 2. We go to number 7. By mathematical induction, number 7, the equation n cubed plus 2n is divisible by dash. So we have what? N cubed plus what? 2n. So that means what we're going to do, we have solved it normally in our, just go and check my video. But for this objective case, what we are going to do is we can put n equals to 1. When you put n equals to 1, you are going to have what? 1 plus 2 what? Times 1 will give us what? 3. Because 1 cube is 1, then plus 2 times 1 is 3. So you get what? 3 as the answer, because the only one that will be divisible by what? By 3 is what? 3. Now, let's go to number 8, which is the last question there. It said what? The sum of what? R, 1, and n of 2r's, sum of what? 2r's minus 1 all square, starting from 1 ending at n, is equal to what? N into bracket what? 2n minus 1, 2n plus 1, all over what? 3. It said what? It's proved by mathematical induction. The principle at n equal to k plus 1 is obtained by solving. At n equal to k plus 1, how will we solve it? Anywhere you see n, put k plus 1. So we have k plus 1 into bracket what? 2 into bracket what? K plus 1, minus 1, close bracket, into bracket what? 2 into bracket what? K plus 1 plus 1, or divide by what? 3. So what we do is that we are going to have K plus 1. 2 times what? K is 2K plus 2, plus what? 1. So bracket what? 2K plus 2 plus 1, or divide by what? 3. So what we are going to do now, this one is minus, sorry, it's minus. So what I want to do now is what? Is to subtract. And if you subtract now, I want to have K plus 1 will still remain. K plus 1. Then 2K, 2 minus 1 is what? Plus 1. 2K plus 1. 2 minus 1. Then 2 plus 1 is 3. Now become what? 2K plus 3. All divided by what? 3. This is 2K plus 2 plus 1. If you add this together, it's 3. 2 minus 1 is 1. And that is this one. Then 2K plus 1. Then K plus what? 1. All divided by what? 3. And that's what I have here. So that will be your answer. Let's check the option. So option A is what? Not correct. B, correct? No, not correct. C, I think C is correct. So I believe you'll be able to enjoy the video. Ensure you watch all the analysis on mathematical induction for proper and comprehensive understanding, for better understanding. That's what I mean by that. Thank you. God bless you.